So this is our final presentation of the problem scenario, generation of photovoltaic energy. Section 1. During the year of 2019, the photovoltaic capacity of 5,000 megawatts was accumulated, and this was enough energy to light more than 25 million houses in Mexico. According to Forbes, in Mexico, 31% of the energy is produced from renewable energy, and 4.3% comes from photovoltaic energy. In this graph, we can see that the generation and use of renewable energies has risen exponentially.
The location of our country allows the adaptation of renewable energies. The president of ASOLMEX said that the energy produced by sunlight increased 62% from 2018 to 2019. The renewable energies, such as photovoltaic and aeolic, they will contribute 29 millions of dollars to the gross domestic product in our country. Now we will review some concepts to understand better how photovoltaic energy work. The first one is photovoltaic cell. That is a device that converts the energy generated by light into electricity due to the photovoltaic effect. A photovoltaic module is a device that works through sunlight, and their primary use is to keep humidity and survive heat. And the cell array is a combination of solar cells and photovoltaic cells that group together to make a solar panel.
Voltage current and power voltage. A photovoltaic panel has two curves characteristic known as voltage current and voltage power, where we can observe how the panel behaves, its value, its losses, the efficiency, and others. In the picture below, to obtain the values in the voltage current, the green curve, we can find them by varying the tension in the x-axis when current equals 0. This causes a short circuit, which helps us see the maximum voltage, up to infinity, which causes open circuit, which helps us see the maximum current. And in the voltage power, the blue curve, we can see the voltage of the panel equals 0 when there is a short circuit and when it is an open circuit. As we can tell from the picture, the maximum power is obtained when the voltage and the current values are in the maximum power. The energy produced annually. In order to calculate the exact energy that is produced annually by a photovoltaic system, you have to use the formula seen in the picture, where E energy equals A multiplied by R multiplied by H multiplied by PR. R is the solar panel yield in percentage, H is the annual average solar radiation on tilted panels, and PR is the performance ratio or the constant for losses it can range. In a photovoltaic system, the DC current that is generated has to go under some losses for it to become an AC current to be capable of being used by us, the people. We use a page to simulate the capacity of the photovoltaic system necessary to generate in our house. In my case, it was 42,456 kilowatts a year. Then we got the 40% of each.
In my case, I got 65,199 kilowatt hour a year.
And in my case, I got 7,364 kilowatt per year.
And finally, in my case, I got 7,228 kilowatts per year.
To test the way photovoltaic cells work, as well as its behavior, we simulated 5 circuits with some differences. The first one is a basic photovoltaic cell with features, a diode and a resistance inside of it. It also has a power source that we simulated as the sun. This results on the 1,000-volt power source voltage, which simulates 1,000 watts over square meter. This is also connected to a 1-volt power source that represents the load. This helps us to see how much the current and the power changes over the voltage. Then we simulated a single module of 6 cells. This is also connected to the 1,000 volt, and it resulted as a max output of power of 57 milliwatts. For this, we changed the current of the photovoltaic cells to 100 milliamperes. After getting the first single module, we connected 2 modules in a parallel way. This to see the behavior of the current and the power in this new array. This array resulted in a 200 milliampere current and a max output power of 114 milliwatts. It also had a max voltage in the open circuit of 0.57 volts. Then for the last 2 circuits, we simulated the same 2 models, but this time in a serial way. This resulted in a 100 milliampere current, max power output of 57 milliwatt, and also a max power voltage of 0.57 volts. This is the circuit that is in series, and both modules have full sunlight over them. Finally, this last circuit is the same as the previous one, but we changed the half of the cells, one module, to have some shadow. So we reduced its sunlight to 70% of its capacity. This resulted in a 70 milliampere current and a 39.99 milliwatt power source, power output. This showed that the shadow affected all the circuit and not just half of the cells.
So, after comparing these 2 graphs of the dual module in a series system, we observed that the current is reduced by the shadow and changes the whole result even when only half of the cells are affected. In the full light circuit, we have as a result a current of 100 milliamperes and a max power of 0.57 watts, whereas in the shadow one it is 70 milliamperes and 0.039 watts respectively. So we can infer that if half of the cells in this circuit are reduced to a 70% of the capacity, all the current and power will be reduced to that new performance. So, after this deep analysis, we can conclude that due to the solar radiation that Mexico receives, it has a lot of potential in being a renewable energy-based country. Nevertheless, even though entrepreneurs have tried their best to make solar energy systems accessible for everyone in the different income sectors, the cost is still too elevated to make such a sudden change in every home. On the other hand, through the simulations of the different circuit scenarios, we can state that in the single and series double module circuits, the current stays the same because it is never divided and remains constant. However, the current and power duplicate in those that are in a parallel circuit. This is because the current flows through both opposite sides. Then we can deduce that if we need to add the current output of two or more cells, we should place them in order to be in a parallel circuit.